Good evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to tonight's video. This one's titled "The Freezer Door is Open." And here's a great example of a freezer that needs some defrosting. You can see how thick the ice is in the freezer, and you have a couple more clear pieces of ice here in the front. All right, so why am I saying the freezer door is open? Wow, we've got some interesting weather ahead. If you're a winter weather person, you're definitely going to get excited about this potential of a pattern. I always use the word potential very cautiously because I myself am a big winter fan that likes the colder temperatures and snow chances. But we do have to. I kind of look at this as cautious optimism. Feeling very confident in the upcoming weather pattern being colder with potential more active storm track. But you just never know. These models change daily. But right now things are looking really great, really, really great. And I'm going to go ahead and delve into those graphics and charts and explain that this evening on the video. All right, so starting off with this Thursday, the 15th of December, we're approaching mid-December already. It's hard to believe as we get closer to the Christmas holiday. Generally here on the left, I'm showing the 12Z, the midday run of the European ensemble on the left. And on the right, I'm showing the GFS ensemble midday run here on the right. So European ensemble left, GFS ensemble right. And so again, what we mainly are looking at here are various levels, or at the 500 millibar level, various features rather, of specific upper level items of interest. Specifically, when we look at brown coloring or brown shading, we're looking at upper level ridges. And typically when you see this brown shadings here, upper level ridges indicate areas that are typically drier and milder. And whenever you see the greens or the purple coloring, that is indicative of lower than normal heights, also known as a trough in the atmosphere. And troughs generally are associated with colder air as well as with more unsettled weather conditions. So what we have going on starting this Thursday afternoon, the 15th of December, the European ensemble here on the left, really both models, GFS ensemble on the right, showing a closed low, generally in the vicinity of eastern Iowa by this Thursday, the 15th of December. We're looking at some troughing, significant troughing, which is developing and extending southwest from the low here down into parts of Missouri as well as Oklahoma. In general, this trough is moving off from the Midwest on Thursday. It'll be moving to the east over time. We see that blocking over the top, generally to the west of Greenland now. So we got blocking occurring just to the east of Hudson Bay. We also have blocking that's extending northward up into the Gulf of Alaska and extending into the Bering Sea. Upper level ridging there, upper level ridging and blocking over just to the east of Hudson Bay over eastern Canada. And then beneath those blocking features, we have troughing, generally lower than normal heights. One center is located across the northwest Atlantic, the other over the Midwestern U.S. Okay. And generally these features are in pretty good agreement between the different ensembles, the European on the left and the GFS ensemble on the right. It does look like the European wants to amplify this ridge a little bit more to a little bit stronger heights or higher heights here across the northeastern Pacific, whereas the GFS ensemble here on the right, not nearly as strong, but the placement of the ridge, upper level ridge, is pretty much spot on in both cases. So in general, in summary here, I write a little summary at the bottom of each of these slides. What I didn't point out is the weak ridging here across the eastern U.S. on this Thursday, the 15th of December. A little bit of weak ridging, rising heights downstream of this digging trough. And so we can see that weak ridging extending all the way up from the mid-Atlantic to New England. And we'll see a brief milder period prior to a strong surface cold frontal passage, which will occur later on Thursday towards evening. Looking at the 17th of December, now we're moving ahead to this Saturday, upcoming Saturday, the 17th of December. You got shopping plans, last minute Christmas shopping perhaps, or just some Christmas festivities to go out there and be a part of, whether it's Christmas parades or local community events outside. We're looking at much colder conditions. The green here really indicates this trough, which has really established itself over the eastern U.S. Over the top, we have that west-based negative NAO, and then over the Gulf of Alaska, right up to the western portion of Alaska, oriented more south to north, we have a strong upper level ridge. It just keeps getting stronger. And we have that ridge axis extending over western parts of Alaska. Downstream of this anomalously strong, highly amplified ridge, we have deep troughing, which is occurring over southwestern Canada. And then we have that other trough, again, located over the Midwest to the eastern seaboard. And so pretty much the model's in good agreement. Again, European on the left, European ensemble, and the GFS ensemble on the right. The placement of the upper level ridge, pretty much right on with each other, in agreement. And then we also have that negative NAO in a very similar position. In addition, we do have the troughing over the Midwest, the eastern seaboard, in both models. Both ensemble runs from midday to day. Looking ahead now to the 19th of December 2022. Okay, so what's going on here? This is where the ensembles get a little different. All right, the biggest difference you see here with the European ensemble on the left and the GFS ensemble on the right is a little bit of ridging that's trying to build in between the upper level troughs. So, the 17th, we have that trough well established in the mid-Atlantic up to New England, right? But by the 19th, Monday morning, the 19th of December, next week, 7 days from now, you'll see that trough kind of basically pull away, going to the northeast over the North Atlantic. And then you have another digging trough over the Pacific Northwest, southwestern Canada, the Pacific Northwest. And in between these two troughs, the European ensemble is trying to develop a weak ridge. If this were to come true, then you would have a very brief period of milder temperatures across the Midwest to the eastern seaboard as this trough moves away. And if this trough digs deep enough here over the western U.S., then that could allow heights to somewhat recover from the colder, lower thicknesses or lower heights from Sunday. And so we could get a little bit of ridging here. Now, look at the GFS ensemble over here on the right. You just don't see that yellow coloring, do you? The higher heights. See this? You still see that upper level trough just off the Gulf of Maine and then extends southwest towards the mid-Atlantic. So there's a big difference here in placement of the trough feature over just off New England down to the mid-Atlantic. GFS ensemble keeping the cold temperatures and the lower heights in place along the eastern seaboard, whereas the European ensemble allows this upper level trough to pull away, and then you get a little bit of weak ridging behind it. Okay, so this is where there's a little bit of difference in today's midday run ensemble models. We move ahead to 23rd of December, things really start locking in as far as agreement between the ensemble members, or the ensemble models rather. European EPS here on the left showing a deep trough well established from the Midwest to the East Coast. By the 23rd of December, we're getting close to Christmas now. You do notice too this coloring out here. Notice how these dark solid lines, these height contours are tending to bend upward towards the north. This is an association with height rises that are occurring just off the U.S. West Coast. This is huge. One other thing I want to mention is that anomalously strong upper level high. Look where it was, okay, on the 19th of December. It was pretty much over the eastern Bering Sea, going all the way up the Arctic, parts of Alaska still, and then watch what happens on this frame. By the 23rd of December, it's way up here over the Arctic, okay? It's north of Alaska, very anomalously strong upper level high, anomalously high heights. And then beneath that, you got that upper level ridging just off the west coast of North America. And downstream of that, you get your troughing, all right? And then look over here, the GFS ensemble forecasting system, very similar. Has the lowest heights a little bit further back to the northwest as compared to the European. So GFS ensemble has the lowest heights over, portions of the Midwest to Michigan and Wisconsin and this general area here. All right. We still see some blocking over the top. You notice that has weakened somewhat, right? We look at the coloring scheme here. It's light brown on the 19th of December. You can see the color scale over here on the right as far as the anomalies in meters. These are meters over here on the right. And so, lighter brown coloring, 280 to 300 meters, anomalously high with this negative-based, west-based negative NAO. And then look at this. It has weakened, definitely, the higher heights by the time we reach the 23rd of December. But overall, we still got this block over the top across the higher latitudes. And that's going to allow this cold air to remain in place across the mid-latitude, specifically the central and eastern U.S. by the 23rd of December. All right, so this is the big thing. One other thing I'm going to mention is we have very cold temps on the 23rd of December. So we have the cold air. That's one of the main items you need for winter storms along the eastern seaboard. The other thing that we're going to be really watching closely is for these pieces of energy. Specifically, when you get the trough this deep, you can sometimes get a disturbance that drops down in through the trough and just kind of pivots around the trough. It moves off the east coast, the southeast coast. We're going to be watching this. I really have a feeling that 20 to 24 December period, that is a big time storm potential period based on what I'm seeing today. And it's going to extend from the Gulf Coast right on up the east coast, right? So I'm still favoring a storm of some sort between that period, 20 to 24 December. Let's go to Christmas Eve now. What's Santa going to have when he comes down to deliver those presents on Christmas Eve? Wow. This is an extremely deep trough. This is European ensemble on the left, the GFS ensemble on the right. Any way you slice this, the features are very similar. The strengths are not. So the European EPS wants to build up this ridge off the Pacific Northwest, wants to make it a stronger ridge there off the Pacific Northwest coast on the 24th of December. Whereas the GFS ensemble not as strong, but we still see the ridge positioning here. All right, we still see higher heights off the west coast of North America. All right, so both cases, the positioning of these ridges is really pretty much an agreement. It's just the intensity; it's stronger. We have a stronger ridge on the European ensemble here on the 24th of December. All right. No matter how you cut this, this is indicative of a positive Pacific North American pattern, PNA. I'll get into that here in a minute. But you can see the digging trough here across the eastern U.S. So we have a strong storm signal in place across the eastern U.S. on Christmas Eve. We have a positive Pacific North American or PNA pattern now in play. If this upper level ridge, the strength of this upper level ridge verifies on the European Ensemble Prediction System, the EPS, this is going to allow for a coastal storm to track up the east coast most likely. And look at this. I even talk about this in the North Atlantic. You see this upper level ridging again in the North Atlantic. All right. Again, what's the main point here? Storm systems, areas of low pressure, are seeking the path of least resistance. They're not going to go towards upper level ridges. They're going to take a path toward the lowest pressures, or the lowest heights in this case. They're not going to be going towards this. So this is a situation where I really don't see a storm system, if it forms off the southeast coast, readily escaping out to sea harmlessly. I think there's major impacts potentially involved here for a winter storm on the East Coast by Christmas Eve this year. And what an amazing timing that is. Hopefully everybody will get to their destination by this point, whether we're talking about the 23rd or the 24th. I see a big signal for storm potential. Now let's look at Christmas Day. Nothing's really changed here, has it? I will say the European ensemble here on the left is showing pretty much a complete connection to the Arctic all the way down to the Gulf Coast, down to the Florida Peninsula. See this? See the blue shading? The lower heights extend all the way from the Arctic Circle down to Florida. This has big time cold potential if the European ensemble verifies here on the left. You see the ridging again developing over the North Atlantic. You got ridging off the west coast of North America. You got ridging still up, upper level high, still up over anomalously over the Arctic area. And then so you got like 3 different areas of higher heights. And beneath that, you're going to get the colder temperatures in the mid-latitudes. And then look at this. This is the GFS ensemble here on the right, showing that ridging. Again, it's less intense. It's not as strong, the ridging with the GFS ensemble midday run today as compared to that European model. So there's different tendencies that are showing up, right, between that European EPS, the ensemble, and then the GFS ensemble. But regardless, this is a nice pattern here. Negative NAO, got that ridging here in the North Atlantic, a negative NAO up to Greenland, higher heights. You've got a negative AO, Arctic oscillation. You've got a negative Eastern Pacific oscillation, EPO. And then you're throwing in a potentially positive PNA with a ridge over the west coast of North America. Now, I want to go into this storm potential. Before I do, I want to explain something. I want to talk about the dynamics, if you want to call it dynamics or ingredients for winter storm development. And I'm always really emphasizing this is where is the baroclinic zone, okay? Now, these are actual GFS midday run graphics here, by the way. Over here on the left, this is the GFS operational midday run today, and this is the GFS, also the 12Z, the midday run here on the right, just for two different time periods. This is 22 December forecast on the left, and this is 23 December forecast on the right. Now, this dark solid line I drew, this is going to be your baroclinic zone and where it's sitting on the 22nd of December, extending from the Western Atlantic down across the Carolinas, the Georgia, all the way down to Louisiana and Houston, Texas. This is where, now what is a baroclinic zone? It's simply that boundary in which you have the strongest temperature contrast between very cold air to the north and warm, moist air to the south. And what do storms really depend upon to get going and get strengthening and intensifying? What determines where the storms are going to track? Well, it's the baroclinic zone. So I'm always looking for this zone on these charts. Where am I seeing it set up? So I drew this in for you to see where the collision point or boundary between warm, moist, MT air, maritime tropical air of the Western Atlantic meets with very cold continental air in winter. You're getting a very strong temperature contrast from one side of this baroclinic zone to the other. Okay? Storms tend to move along this baroclinic zone as well. Here is where the baroclinic zone sets up for around the 23rd of December. And you wonder why I'm so big on a potential big storm between 20 and 24 December. There's indicators here that I look for, and this is one of them, where the baroclinic zone is sitting right here. See this? So very interesting. And, in this case, it had snow all the way down to Texas, ice all the way down to northern Louisiana, northern Mississippi, northern Alabama, and then some, heavy downpours across Interstate 10 corridor from Biloxi over to New Orleans. Now, is this going to happen? Like, these runs are going to change constantly. So the answer is no. It's not going to happen exactly like this, all right? But I just wanted to show you one of the ingredients I look for these winter storm development. The baroclinic zone, where is it? Now, if it's this far south or suppressed, wow, we definitely could see a more active pattern with this kind of southern storm track. More wintry weather across the mid-Atlantic and potentially all the way up into New England. Now, if I look at some of the dynamics here in the bottom, what am I looking for? What's associated with this baroclinic zone? At the surface, you typically have this stationary frontal boundary initially, where it's at the surface and you have cold air to the north, warm air to the south, but really there's no wave of low pressure developed along it initially, along the front. So basically the cold air and the warm air are blowing parallel and opposite directions to each other in this case. And then maybe at the higher up aloft at 500 millibars here, you have your height contours are basically paralleling your isotherms or lines of equal temperature. So you get no type of advection of any kind. Now, advection is just simply a transfer of any atmospheric property horizontally. That's all that is, advection. But we do have a sharp thermal boundary here. We have a stationary boundary associated with that baroclinic zone. And then what happens over time is you get this upper level trough at 500 millibars, this little short wave. Out ahead of a shortwave trough, you get what's known as positive vorticity advection. So we're getting higher values of vorticity blowing into an area. You're also getting warm air advection in association with that. In addition to the positive vorticity advection, you're getting basically a wind blowing across these lines of equal temperature, these isotherms. So you're getting some sort of temperature advection or change, and that's what we want. So we got an upper level trough. It starts to interact with the surface low, or the frontal boundary initially, develops this surface low, and next thing you know, you got sinking air associated with high pressure, cold high pressure behind the storm system, and then you get warmer, moist air rising ahead of this area of low pressure. So we have our warm sector, our cold sector. We have the upper level dynamics in place as far as at the 500 millibar level. We have thermal advection going on, cold and warm air advection. We have vorticity advection. And this is really what ignites the storm systems. So at that baroclinic zone, to review, you have a surface stationary boundary. It's not moving at all. You have cold air to the north of it, warm air to the south of it. You got a sharp temperature gradient though on both sides of this front. And then you get a little upper level disturbance and vorticity moving overhead over that stationary boundary, kicking off this area of low pressure, and voila, you got yourself a mid-latitude cyclone. What happens? What else do we need? Okay, we need to look at Again, upper level vorticity. This is an example of a vorticity chart here on the right. See the orange coloring? The brighter oranges indicate the higher values of positive vorticity. And so whenever the winds are blowing higher values of vorticity into your area, we call that positive vorticity advection. We're increasing the positive values of vorticity. Whenever you have positive vorticity advection, which typically occurs ahead of these shortwave troughs, you typically get rising vertical air motion in association and upper level divergence, removal of mass aloft. And so what happens is out ahead of these little pockets of energy, we call them pockets of energy, but really what it is positive vorticity. These are responsible for initiating that upward vertical motion from the surface where we live all the way up through the vertical realm of the atmosphere. Further up from this level, this is like at 500 millibars or 18,000 feet above the ground, we're looking for these vorticity pieces, positive vorticity areas. We also are looking for an area where the winds are accelerating in the jet stream axis. These are known as jet streaks. Okay. In this particular graphic, I'm showing the orange coloring here. This is a typical looking jet streak. And why is this important? Mainly because as air accelerates through these regions in the jet stream axis, it tends to lead to what's known as ageostrophic balance. So things are temporarily out of balance in this case. As an air parcel enters this jet streak, it wants to speed up, right? There are some factors here we got to look at, which, if I were to divide up this jet streak into four pieces, just put four quadrants and put a plus symbol over this. The left front quadrant and the right rear quadrant are the areas which are favorable for storm development and vertical rising air motion, clouds, and precipitation. Left front and right rear. Whereas the right front and the left rear are associated with sinking vertical air motion. And when you get sinking air in the atmosphere, it generally leads to clear conditions. Okay, so we look at where we're at in relation to these jet streaks. Okay, we divide this up into four quadrants. If we're in the left front and right rear quadrant, that's the areas that favor storm development and upward vertical motion of air. If we're in the right front and left rear again, we have sinking air motion and fair weather. So we have a nice piece of energy at 300 millibars here at the jet stream level at 30,000 feet to work with. And what happens ultimately is, you have very good dynamics at 300 millibars if you're in the left front or right rear quadrant for rising air motion, clouds, and precipitation. If you have the vorticity at 500 millibars, this positive vorticity advection or increasing values of vorticity getting blown into your area by these upper level winds at 500 millibars or 18,000 feet, that's favorable. And then again, where's the surface baroclinic zone? Where is it sitting? And in this case, when you get these very cold shots of air that come down from Canada, sometimes that baroclinic zone and the resultant stationary frontal boundary at the surface can just sit there for days until this upper level energy moves overhead at 500 millibars and starts interacting with that front, kicks off an area of low pressure or storm development, and the rest is history as this thing goes through its life cycle. So just want to talk to you about that. Now, let's take a look at the 12Z midday run charts. This is a European operation on the left. This is the GFS midday run from today, the 12th of December 2022 on the right. Right, this is the forecast from the European on the left and the GFS on the right. This is for the 20th. The 20th of December is over here for the GFS. You kind of see a piece of energy here. And then additionally, we have some energy down here on the 22nd of December on the European. So what I'm getting at here by just showing you these two charts between the two major model runs, American GFS and the European, is we're having energy that is rotating around the base of this trough. We're having energy in the far southern areas along the Gulf Coast. We have a couple pieces of energy. It's amazing. I'm telling you, we got the cold air to the north, set basically in good position. All right, we got a baroclinic zone suppressed further south. All right, so all these ingredients are coming together. Now, these models will continue struggling with the placement of this storm energy, but I just want to show you these because I believe it's important to. The overall synoptic pattern is the main reason I want to show you. It's very favorable for winter storms from the Gulf Coast right on up off the U.S. Southeast coast to the Mid-Atlantic for sure, and potentially working its way all the way up into New England. All right. and it's looking very favorable. I want to show you that. Now, this is another piece of energy. This is a different one. This is the GFS midday run today. There's lots of energy here further south. This is a new piece of energy. So you have, the European showing it on the 22nd. The GFS is showing it on the 23rd a day later. So these two charts kind of jive. This one here on the left, European 22 December. This one, GFS 23 December. Bottom line is there's a lot of energy here. There's a lot of moisture to work with. The Gulf of Mexico is open for business. You got very cold Arctic air just sitting here to the north and back to the northwest over parts of Texas. We're seeing, this energy. It comes and goes from model run to model run in the operational runs, but it keeps coming back. You're looking at trends, right, for these runs, and you kind of see it go away and then come back. But this could be a doozy of a storm if this comes to fruition. Right before the Christmas holiday, if people are traveling, folks that live in the south don't, they just don't have that same equipment up north to clear these roads and keep these roads safe for driving. So this could be really interesting, and definitely not going to say it's going to happen exactly like this, but look at the features in place. Cold Arctic high pressure to the northwest, clockwise flow around it, keeps funneling in Arctic air at the surface, low pressure forming along that baroclinic zone, the stationary boundary there over the Gulf of Mexico. This just smells like a good pattern. All right, so now let's take a look at some of the temperature anomaly forecasts. This European ensemble mean. I'm starting off up here in the upper left, 19 December. That would be next Monday. The green coloring indicating colder than normal temps. Purple, very much below normal. The coldest anomalies out of everything is purple on this. And then, the browns and the maroons and the oranges are warmer than normal temperatures. So you see a little bit of a warm area come up from East Texas to Illinois by next Monday, the 19th of December, according to the European ensemble mean. Cold on the East Coast, very frigid across Montana into the Dakotas. By the time we move here in the top center, that very cold air is coming down into the northern plains, and then you got somewhat of a moderation occurring on the East Coast by the 20th of December, according to this model. But that's very brief, because by the 23rd, look at what happens. Barney the dinosaur shows up. Barney, whenever I say Barney's coming, I'm talking about these purple colors, right? Looks like Barney the dinosaur, okay? And look at this cold, stretching from the Dakotas down all the way to the Gulf Coast. That includes you, Houston. That includes you, New Orleans. That includes you, Mobile, Alabama, and all the way down to the Orlando. You're not out of it. It's very chilly conditions even for you. And so much colder. This thing really takes over the 23rd of December, these colder than normal anomalies. And then bottom left here showing, this would be for the 25th of December, Christmas Day. Look at the greens, widespread from the Rocky Mountains to the East Coast, all the way to the Gulf Coast. Below normal temperatures, a cold Christmas for many in the East and the Midwest. And then finally, over here at the bottom right, we see 27 December, and that cold is still locked in there generally from just to the west of the Mississippi River to the East Coast. Now this one, temperature anomaly forecast, this is EPS control. Cold air on the East Coast on the 19th of December here in the upper left. There's Barney. Barney's lurking. He's up there in the western provinces of Canada. And then you got this nice little warm pocket of air extending from the Gulf of Mexico, working its way up towards Kansas City down to Houston. And then by the time we get to the 20th of December, you kind of see that moderating trend again showing up on the models here on this particular European ensemble control. Warmer temperatures briefly, but and then they still kind of hang on the 23rd of December according to the European control 12Z run. That's a little bit different than this one, right? This is the mean, much colder. This is the control, warmer on the eastern seaboard on the 23rd of December. But nonetheless, by the time we get to Christmas Day, it's cold on the control as well. There's your Barney extending from North Dakota down to Illinois and all the way to the Southeastern U.S. Gulf Coast. You're cold. Grab your coats. It's going to be a chilly Christmas if this comes true. And then over here on the right, still, this is the 27th of December after Christmas, still very cold from Iowa, Missouri, Illinois, working its way to the Ohio Valley, East Coast down the Gulf Coast up to New England. So, and I tell you what, these models are in pretty good agreement. Now, additional model on temperature anomaly forecast. This is European control from today's midday run. This is for the 22nd of December. look at Barney here, the purple coloring. From Western Canada right on down to Montana. Look at eastern Montana, 35 to 40 degrees Fahrenheit below normal in eastern Montana. Same thing for eastern Wyoming, as much as 40 degrees Fahrenheit below normal western Dakotas. Wow, this one's going to sting. This one's going to sting a little bit. And then that cold air working its way all the way back to the mid-Atlantic, okay, where we're at 10 to 15 degree Fahrenheit anomalies across the Carolinas and Virginia. And then over here on the right, this is a completely, I just want to throw it in there for comparison differences. This is the Canadian 2-meter temperature anomalies in degrees Celsius. This is for the same day, the same time on the 22nd of December. Look at the surge of warm air that goes all the way up to the Ohio Valley, the East Coast, New England, ahead of this crazy strong Arctic front, this boundary here setting up. So there are differences that still need to be resolved between some of these operational runs anyway. All right, so now let's take a look at the Teleconnections forecast, North Atlantic oscillation forecast first. EPS is on the left, and then the JEFs is on the right. I'm circling this in red. This is the NAO forecast. I'm circling this in red for a reason. Watch the period from 20 to 24 December for East Coast storm development. This one could be a big one. Whenever the NAO starts relaxing, look at this, how it's starting to come up a little bit more and more closer, still negative, but it's not nearly as sharply negative as it once was, right? So watch this period. Very similar forecast for the NAO between both these ensemble runs. Look at the AO forecast, negative throughout the entire period, all the way to 28 December. There is no jump back to the positive side. I mean, if you look at this right here, 18 to the 21st of December, the AL could be down to almost a -5 magnitude value. Just impressive stuff. PNA, Pacific North American forecast. This is another reason why I watched that 20th to 24th of December period. Not only do we have a NAO that's somewhat relaxing a little bit, but we also have now the forecast for both the ensembles, the European on the left and the JEFs on the right, showing a temporary rise into positive territory for the PNA forecast. This didn't exist a couple days ago, this strong of a positive signal. So this could really build up that ridge in conjunction with a negative EPO across the Western U.S. and Western North America, and that's going to result in a deeper trough to the east. This could enhance the colder temperatures and deepen that trough further across the east. So watch this period here. And then the Eastern Pacific Oscillation EPO forecast. This thing crashes hard negative, reaches its peak negative values around the 16th to the 18th of December on both models, and then slowly works its way back up closer to neutral just after the Christmas holiday. Here are my final thoughts in tonight's video. There is so much to be excited about if you're a winter fan of the Eastern U.S. Today's midday model runs, very similar. Been really sticking to their guns over the weekend. A cold look is definitely there. There are some differences in temperature anomalies, with GFS being the coldest of the midday model run out of all the model runs. The models are leaning towards the establishment of colder air into the eastern U.S., definitely by this Sunday, the 18th of December. And I can say that with a high degree of confidence. And the Climate Prediction Center is showing below normal temperatures for a good chunk of the U.S. by this point in time, by this Sunday, the 18th. So definitely leaning towards the colder air, high confidence through Sunday, the 18th of December. Now, where the models diverge somewhat is after the 18th. It's the beginning of the early part of next week. Monday, the 19th of December, Tuesday, the 20th of December. There's low confidence right now. Some of them are showing this brief warm-up in the east before that really, really cold shot comes in, behind a very strong Arctic front. So low confidence on this one right now due to the greater model differences early next week as far as temperature regime goes. But very high confidence once again once we get the very cold air returning on 21 December and persisting right on through Christmas Day. This looks like a very cold period really that week. And then finally, my last slide tonight, the teleconnections are lining up to produce a very cold temperature period across the eastern U.S. We're looking at a negative NAO, a negative AO, a negative EPO, and that positive PNA from 23 to 26 December. This is going to be cold air. Big storm potential between 20 and 24 December. Now, that's what I'm really seeing right now still. The storm signal is so big right now for this period of time. The geographic area is going to be anywhere from the Gulf Coast up the East Coast. So just want to put that out there right now. But there are additional storm threats that loom outside of this window, 20 to 24 December. There are some additional storm threats prior to right around the 20th of December. And then there is another one behind this time period, so on the back side of it, just after Christmas. What is so important is where that baroclinic zone sets up ultimately. Where's your sharpest thermal contrast, your temperature contrast? Where's it going to set up? I expect a lot of model volatility and changes from run to run as far as hammering out the specific details for the storm tracks and their intensities. Look, the models are trying to figure out all these different pieces of energy that are just roaming around on a more suppressed baroclinic zone. So the models are really trying to figure this out still. And it's going to take some time before they can actually do that. So I'm not putting a lot of confidence right now in any of these tracks. I'm not. Where these storms go right here, they form here over the deep south along Interstate 10 back in Texas and Louisiana. Where they go from there remains to be seen. There's a lot of variables here. For example, where does this Arctic high set up? Where is this position in relation to the Mid-Atlantic, to New England, when these pieces of energy come out? Where is the coldest air situated when these pieces of energy come out? Will these two pieces of energy phase, where you get a northern stream piece of energy phasing with a southern stream piece of energy at the perfect time? Timing, and location. That will really tell us what's going to happen. But, I just wanted to show you these charts because they're indicating that active southern, more suppressed storm track. That could lead to a potential white Christmas in areas that normally don't get that. Okay. All right. So there could be, there will be a lot of model volatility from run to run. But here it is. The potential is there to see a cold period overall beyond the 18th of December, leading up to Christmas, 25 December. And that colder air could last well into early January. That one's a little bit further down the road. So I'm really focused on that week of 18 to 25 December right now. Again, will that precipitation, will that energy align with the colder periods or a milder period? We could be looking at a case where, we get one of these situations where, the storm track is a little bit further to the north and perhaps it curves a little bit more inland up towards the Ohio Valley or something like that. And it could drag up a brief period of milder temperatures, and that's going to make it all rain. You're in the warm sector, it's all rain. But I don't see that right now. Look how suppressed the storm track is, and look where the Arctic air is sitting. All right, but again, 2 days from now, this could all change. But I'm just letting you know right now what I'm seeing based on the models today on the 12th of December, 2022. All right, it's looking really good if you want a white Christmas across many areas, Southeastern U.S. up to the Mid-Atlantic, up to New England. It's looking really good there. Higher than normal chances than you normally would get. I mean, I've sat here in Virginia and there's some Christmases that are just like 65 to 70 degrees during the day. And it's not even cold yet. It doesn't even feel like Christmas, doesn't even feel like winter. And now we have this potential. So, all right, that's all I've got tonight, everybody. I hope you enjoyed the video. I'll keep following this stuff closely and hopefully get videos up here every few days or so. Until next time, everybody, take care and God bless everyone.